Let's analyze the cost components for a shoreline electrical installation, including bringing power from a generator to a main lug-only panel and wiring various loads. Firstly, we'll examine the material costs. The estimated cost for number 4 use aluminum cable running 200 feet at $1.50 per foot is $300. Secondly, the underground feeder cable, UF cable, is estimated at 500 feet at 75 cents per foot, totaling $375. A main lug-only panel and associated breakers are estimated at $300. Conduit and fittings are projected to cost $150. Lights, switches, and motors are estimated to cost $600. The total estimated material cost is $1,725. Now let's look at the labor costs. Running the cable is estimated at 20 hours at a rate of $75 per hour, totaling $1,500. Installing the panel and lights is estimated at 4 hours at $75 per hour, resulting in $300. Installing the motors is estimated at 6 hours at $75 per hour, totaling $450. Therefore, the total estimated labor cost is $2,250. Adding the material cost of $1,725 and the labor cost of $2,250 gives us a total estimated cost of $3,975. It is important to remember that this is a ballpark estimate, and actual costs may vary based on factors such as material availability, prevailing labor rates, and specific site conditions. This estimate assumes that the generator is already in place and that the property is ready for the electrical work to commence. A 10% contingency should be considered for unexpected expenses. The breakdown includes the cost of running number 4 use aluminum cable from the generator to the main lug-only panel, the UF cable for the pier walkway lights, boathouse lights, and jet ski and boat lift motors, the main lug-only panel itself, and the breakers. The estimate also covers the cost of conduit and fittings needed for a proper installation. The cost of the lights, switches, and motors themselves is included. The labor component encompasses running the cable from the generator to the panel, installing the panel and lights, and installing the motors for the lifts. The contingency accounts for any unforeseen issues that may arise during the project. When assessing the appropriate wire size, consider the ampacity requirements outlined in the National Electrical Code, NEC. Table 310.15b16 provides ampacity ratings for conductors based on insulation type and installation conditions. For aluminum conductors, the ampacity will be lower than for copper conductors of the same size. Therefore, it's crucial to select a wire size that can safely handle the anticipated load current. For direct burial installations, use cable is commonly used because it is designed to withstand the harsh conditions of direct contact with the earth. UF cable is suitable for underground feeder and branch circuits. Ensure that the burial depth meets the minimum requirements specified in the NEC. The main lug-only panel should be sized appropriately for the anticipated load. Calculate the total load in amps and select a panel with a higher ampacity rating to provide a margin of safety and allow for future expansion. Circuit breakers are essential for overcurrent protection. Select breakers with the appropriate ampacity rating for each circuit. For motor circuits, consider using inverse time circuit breakers or motor-rated circuit breakers to accommodate the inrush current during motor starting. Grounding is a critical safety measure. Ensure that the grounding system is properly installed in accordance with NEC Article 250. This includes grounding the panel, the generator, and all metallic enclosures. Ground rods or other grounding electrodes may be required. When installing conduit, use the appropriate type for the application. Rigid metal conduit, RMC, intermediate metal conduit, IMC, or electrical metallic tubing EMT may be suitable depending on the location and exposure to physical damage. Use appropriate fittings to ensure a watertight and secure connection. For lighting circuits, consider using energy-efficient LED fixtures. LED lights consume less power and have a longer lifespan than traditional incandescent or fluorescent lights. This can result in significant energy savings over time. Switches should be rated for the intended use and installed in weatherproof enclosures if exposed to the elements. For motor circuits, use motor-rated switches that are designed to handle the high inrush current of motors. The motors for the jet ski and boat lift should be properly sized for the load. Consult with the lift manufacturer to determine the appropriate motor horsepower and voltage. Ensure that the motors are protected by overload relays or other protective devices. When connecting the generator to the panel, use a transfer switch to prevent backfeeding onto the utility grid. Backfeeding can be dangerous and can damage electrical equipment. The transfer switch allows you to safely switch between the generator and the utility power. It is essential to comply with all applicable codes and regulations. Obtain the necessary permits and inspections before starting the work. Work should be performed by qualified electricians. Remember that this estimate is based on certain assumptions. It is important to verify these assumptions and adjust the estimate as needed. The actual cost may be higher or lower depending on the specific circumstances of the project. This includes the type of soil present at the location as it relates to digging and ensuring the correct depth is installed for underground cables. Also, ensure that if there are any rocks present that the correct methods are utilized for protection from damage. The estimate assumes standard labor rates. Labor rates can vary depending on the location, the experience of the electrician, and the complexity of the job. Obtain quotes from multiple electricians to get a better understanding of the prevailing labor rates. The estimate includes a 10% contingency for unexpected expenses. This is a reasonable contingency, but it may need to be adjusted depending on the complexity of the project and the potential for unforeseen issues. Remember that electrical work can be dangerous. If you are not qualified to perform electrical work, it is best to hire a qualified electrician. When considering materials, you could consider using copper wire instead of aluminum wire. Copper has a higher conductivity than aluminum, which means it can carry more current for the same wire size. However, copper is also more expensive than aluminum. Consider the pros and cons of each material before making a decision. When running cable underground, be sure to follow the NEC guidelines for burial depth. The burial depth depends on the voltage of the cable and the location. The NEC specifies minimum burial depths for different types of cables and locations. Using PVC conduit can offer physical protection to the wires. If you choose to run the cables in conduit, be sure to use the correct size conduit. The conduit should be large enough to accommodate all of the wires. Also, be sure to use the correct type of fittings for the conduit. There are different types of fittings for different types of conduit. If the project involves working near water, be sure to take extra precautions to prevent electric shock. Ground fault circuit interrupters, GFCIs, should be installed in all circuits that serve outlets near water. Also, be sure to wear appropriate personal protective equipment, PPE, such as rubber gloves and boots. Consider obtaining multiple quotes for all of the equipment that needs to be purchased to see where you can get the best prices. Sometimes purchasing in bulk can save on overall costs as well. Always review all completed work to ensure that there are no exposed wires or issues that could become safety hazards in the future. Make sure the customer is aware of how to operate any switches and other equipment and offer troubleshooting tips as needed. Make sure all wires are properly labeled so that any future work can be performed without guessing as to the purpose of any wire. Having clear labels will make it easier to trace circuits and ensure that the correct wires are being worked on. Consider a surge protection device for the whole panel. Surges can come from many different sources, including lightning strikes and power outages. A surge protection device can help to protect electrical equipment from damage caused by surges. Ensure there is proper labeling to indicate that there is a generator connection to the panel and how to safely switch over to generator power if needed. Also provide guidance on how to disconnect the generator from the panel when switching back to line power. If the generator is portable, the homeowner may have it some distance away from the panel when in use. This could potentially mean that the homeowner would need to walk some distance in inclement weather to perform the connection. Make sure the generator is connected to earth ground in addition to the panel being grounded. This will create additional safety for the homeowner and for any future workers. If a permanent generator were to be installed later, a more complex automatic transfer switch and associated wiring would be needed. If the homeowner anticipates this in the future, it might be wise to consider the physical location of the panel and the route from where the generator may be placed. In general, it is wise to overestimate costs, as unexpected problems can occur that could not have been anticipated.